I'm Gareth, and today I'm excited to share a project that I worked on called Fable Flux. This is a project where I fine-tuned a open source large language model, GPT-OSS, and the 20 billion parameter model into this sort of magical storyteller for kids. And this was part of a hackathon for I guess the release of GPT-OSS. Storytime is this sort of powerful thing to sort of shape imagination, language, and confidence in kids. But sometimes you sort of run out as a parent of fresh ideas, and kids sort of love hearing stories that feel personal. So this question came up, which was, can these open models can I learn something from this open model, fine-tune it? And that's what sort of led to this project called Fable Flux. I started out by curating some stories, and the challenge really was to make sure that it was safe, age appropriate, and positive. And open models have this flexibility, but they don't come sort of tuned particularly for children, and that's where some of the fine-tuning came in. So let me give you a quick demo of the product, and then we'll walk through sort of how it was built, what happened. So let's jump to what it is. So this is the website, and I can say Jones, the magical ballerina. Generate a story. And then I get this this story to read with the characters. And it generates this, and this is using a 20 billion parameter model. There's also some others. Let's try one more. The brave little blue car. So you can see this is a thing about Benny the blue car, me the car mechanic, and it has a bunch of characters in there that's been generated. So I started to write out these collections of stories. I think in the last session I walked through this data set on Hugging Face. Let me find it. Make sure I don't. And you can see this data set. So last time we built basically some synthetic data. Since then, in between then and now, I had spent some time with this data. And then I fine-tuned that data. So one part of back, you'll see these fine tunes that I did here. Let me walk you through this. So this took the data that we fine tuned. Let me find VS Code. So this takes that training set that I just mentioned here, the children's story set data, I put it into, and then I use Path to do some fine tuning on the data. So to start with, I get a bunch of libraries to use. I then basically import the set of libraries that I need to do. The next thing is to set up the tokenizer based on the model. So like this will take the tokenizer from the base model and make sure that you use it. We'll also take the chat template and make sure that that's set up. And then load the data set and convert it to these chat-friendly messages. So there's like messages in the system and user. This is how I plan to sort of use it. There's some formatting that we do on the chat template. I'll then load the base model and disable some caching for the checkpoints. Then I set up Path to do the to start with the fine tune. So like we start with we start pretty conservative, and then we'll use SFTT trainer for the training. So we get this adapter. When the adapter's in place, we can then like actually start to test it. So the adapter is also on Hugging Face. So we go back here, my profile, you'll see the adapter in here too. So in the files, this is this adapter model that we used. I then pushed the adapter and then deployed it through modal. So when I go here, there's sort of different ways to Notebook has a thing and there's a front end. I'll get to that in a sec, but the serving is super interesting. So there's this company called Modal. Maybe if you can't see my screen. Let me go back. I just jumped from the notebook that I have here to this serving. Here we have this model name, which is in reference to the same model name that we have on Hugging Face here to do serving. So this just is the pushed fine tune. And then Modal basically is this company that provides inference that you can use to run inference on a model, and it provides this like web endpoint that you can hit, which is super cool. How that works is that it takes an image. Here I take CUDA, vLLM provide this pretty nice library for to support GPT-OSS. I then specify the model name, put this model name through the web server, and then just host it basically. So I can hit requests to this endpoint when it's when a request comes in. To make this like more tangible, I did put together a front end that I should know for this, and this is powered by React. So this is just a React app basically that serves these pages. You'll see it here, and then there's just a proxy here that goes out, which you can use the API key, and this handles the route. So when I do this, you look at the network requests. Is this going to load? This will hit that completions endpoint with the prompt little car, and then it will respond with this JSON object from the model itself. And this is how we get this. Oops, You cannot see my screen. Let's do this one more time. There is a completion request. It sends a request out to complete to this completions endpoint. It just has a prompt. Probably should have a different name, but just in the interest of time. And then I did do that, and then this just produces this JSON object that folks can use to consume the API. Let's talk more about some of the challenges that we ran into with this. Creating the data set was pretty difficult, and sort of going through that work last week. So like providing some safety for that just took some time. Let's maybe walk through a diagram of the stuff that we did. Let's open up Figma. We go to a diagram. Let's start drawing. Okay. Whoa, that's small. Let's try and zoom in. Okay. So basically you started out with this human data set. From the human data set, we got in another layer here, which is the synthetic data. So it becomes like a much larger data set. Then with this data set, we did a fine tune on the data. I hate going down. It's hard for me to all run out of space. Then we did this fine tune. Then from the fine tuning, we did hosting. So put that on Hugging Face. Then from Hugging Face, we went to model serving. Put that on the modal, and then we built this like React app at the front of all of this. Some challenges, I think, is just like this area right here is can I change the transparency? Model serving was a problem, and fine tuning, I think, was a challenge. Let me walk you through some of those things. So to do the fine tuning, let me start with, let's call this challenges. Start with, I normally use one was just like finding an inference provider. So normally I use this company Hyperbolic for model hosting, and I like had some instances that I used to do the training, but like sometimes these H100s are not available, so like a couple of times I just didn't have any. I don't really need 8, but just need really 1 to do it on the 20 billion model. So like I couldn't find that didn't work for me. I ended up going to RunPod to do most of the training. So in RunPod I had to like I typically just pick like one of these older. I like, for some reason I like A100s, so like I just picked one of the A100s and left it for a while. So the finding inference was like number one. So I ended up just using RunPod to do that, to help with some of the training. Basically what RunPod provides is if I can click on any of these models, I click on any of these GPUs, and I can access the GPU on an hourly rate. So I can just like get access to this A100 for like 30 minutes, an hour, or whatever it is, and they'll just charge me for it, which is kind of nice. And that's typically where I'll I find this to be like super useful. So started with Hyperbolic, ended up going with RunPod to do the training run. The training run that I talked about earlier is in that notebook file in Notebooks. I could also show you it in this repo. So it has the notebooks in here too. That is in here. That did the fine tuning. It doesn't have a way to save state because I was like in. This creates a Jupyter notebook in RunPod provides you with this Jupyter notebook when you set it up. So I wish it would have saved state, but yeah. So finding inference was a pain. Hosting, for some reason, there was like some slowness with Hugging Face uploads. I ended up having to like use the Hugging Face CLI to do the model uploads. I think this might have been just to do with the pod, but like that was sort of one challenge that came up in the hosting side. Model serving just took a while. Modal support for... Like I started out just trying to vibe on getting modal up and running, and then I came across this modal GPT-OSS guide, and this was like super helpful because they use this like 4-bit MKFP4 format for the MOE layer, for the mixture of expert layers. So this was super helpful to like get the model inference up. So like appreciate folks that did that. So that was super helpful to sort of get unblocked. Whoa. Did we lose everything? No. The GPT-OSS. And it just took time to load the model. So those are really the main, I would say, like challenges. Some things that I think key learnings from this. The fine-tuning thing is like becoming much easier. I think that's improved a lot since maybe this time last year, maybe just beyond that, I did some Gemma fine-tuning. And I think it's just become like there's just way more information about fine-tuning now that I think makes it easy. I think the data set is probably just like where I learned the most in this project. Frankly, it's just like getting the synthetic data set, generating it in a way. I think if I was to do it again, I'd probably just spend some more time in this area to work on this data set. The other thing that I did not spend time on that like would have been useful would have been evals. Like I didn't do any evals. There's like a bunch of talk right now about evals not being that useful, but like I think that spending some time on the evals would have probably just like yielded a better fine tune than we have today. I think that was probably some things that I would have done differently. It was also like super rushed to do this last section around model serving, like that I probably would have maybe spent some more time on going forward. So maybe to wrap that this was a pretty different stream from previous times. I figured it was useful given that I'd spent quite a bit of time this week on getting this end to end. I wish I could have streamed the entire thing, but I didn't have much energy to do that. So last week we worked on the data set and then the fine tuning, the sort of serving piece. I did in the background, and I figured it would be maybe faster for me to go through this. Otherwise, that video would have been 2 or 3 hours long. Yeah. With that, if you spent any time watching this, I appreciate it. If you have ideas, suggestions, anything at all, just feel free to reach